Welcome to the University Utara Malaysia School of Computing. I am Dr. Ala Jabbar Al-Maliki. This is Lecture 6, Intellectual Property Disputes in Cyberspace. Today, we are examining how traditional intellectual property protects innovation, how cyberspace dismantles those protections, and which ethical frameworks dictate how we build technology. Intellectual property refers broadly to creations of the mind. In computer science, this encompasses software codebases, search algorithms, and digital media formats. In the physical world, property transfer is zero-sum. If you hand that object to someone else, you no longer possess it. The law relies on this physical scarcity. Digital environments, however, operate at zero marginal cost. A compiled software binary can be copied and distributed to 1 million users instantly, leaving the original perfectly intact. A global network without friction severely compromises historical definitions of ownership. Because digital artifacts ignore the laws of physical scarcity, trying to apply traditional property laws to cyberspace creates immense systemic legal friction. To understand how the law governs digital artifacts, we categorize them using this 4-quadrant IP matrix. Copyright protects the exact expression of an idea. In our field, this applies directly to source code and digital media files, preventing unauthorized duplication. Patents protect functional inventions and specific processes. Hardware manufacturers rely on these to secure the exact methods they use to integrate their hardware with software interfaces. Trademarks serve as a legal shield for brand identity. They maintain consumer trust and distinguish legitimate services from imposters within a digital space. Trade secrets protect confidential business logic. Unlike the other categories, this protection is entirely dependent on keeping the information hidden from public view. Consider a search engine weighting algorithm. A company will usually choose to keep this a trade secret rather than filing a patent, because a patent legally requires publishing the mechanics of how the algorithm works. These 4 categories successfully incentivize creators to invent, but they do so by intentionally restricting societal access to that new knowledge. Every piece of software deployed to the internet must navigate a maze of these 4 distinct, invisible legal fences. Watch what happens to the IP matrix when exposed to a global network. The legal definitions fracture. The catalysts for this breakdown are peer-to-peer file-sharing protocols and instantaneous streaming technologies, which distribute data constantly and perfectly across the globe. This reveals a deep jurisdictional paradox. Cyber technology routes traffic across borderless, unified networks, but intellectual property laws are strictly sovereign and geographically bound. For instance, a server physically located in a legally permissive country can host a proprietary file without violating any local statutes. A user halfway across the globe can then download that exact file into a jurisdiction where possessing it constitutes a severe IP violation. Global digital piracy does not exist in spite of the internet, but thrives specifically within the legal blind spots created by conflicting geographic jurisdictions. The legal mechanics we just covered stem from specific ethical philosophies. We can map them onto this triad diagram to understand why these laws exist. The utilitarian view suggests society protects IP purely to provide an economic incentive. The assumption is that financial reward maximizes overall innovation. The natural rights view argues that a software developer inherently owns their code simply by virtue of having authored it. The output of their labor belongs to them. The social good view argues that knowledge and digital tools should be shared openly to benefit humanity as a whole. No single theory resolves all conflicts in cyberspace. A strict natural rights approach might lock away life-saving software, while a pure social good approach might bankrupt the developers building it. The open source movement operates as a direct structural manifestation of the social good and common good approaches. Rather than locking code by patents, open source relies on radical transparency, collaborative engineering, and free access. This model prioritizes widespread accessibility over exclusive creator compensation, standing in direct contrast to proprietary IP. The success of the open source ecosystem demonstrates that massive technological progress can occur by entirely rejecting traditional compensation models. When these philosophical frameworks collide in the open market, we see distinct real-world outcomes. Software piracy illustrates the friction between frictionless replication and copyright law. The ease of copying directly undermines the creator's natural rights. Corporate patent wars over smartphone technology highlight the tension between protecting proprietary innovation and stifling market competition. Companies use patents as weapons to block rivals. On the other hand, widespread enterprise adoption of Linux provides evidence for the common good approach. It delivers vast practical benefits through open accessibility and collaborative maintenance. The exact same digital environment simultaneously produces vicious billion-dollar proprietary litigation and immense free global collaboration. Intellectual property laws are built to protect digital creations, but borderless networks actively encourage violations. The modern computing industry requires continuous adjustment to balance securing creator rights against ensuring public access to knowledge. Now we turn this over to a practical class activity. Take a look at the discussion prompt on screen. You need to prepare your arguments by analyzing this prompt through the 3 ethical theories: utilitarian, natural rights, and social good, while evaluating the economic impact on the computing industry. As future computer scientists, the code you write and the licenses you attach to it will ultimately determine which of these ethical frameworks controls the future of cyberspace.